Welcome to today's session on foundations of data science for the non-technical professional. So what I would like to share with you today is some of my experiences working with data over the last 20-something years. We'll discuss what data science is and how potentially it can help organizations, together with some examples of how that is done. And at the end of the session, I will also show you a couple of quick demos just to give you an idea about data science, how to go about it, and what its possibilities are. So, excuse me, before we start, I just would like to get a quick idea about your opinion. What exactly do you want to know about data science? Do you have any ideas? Do you have some projects in mind? Please use the chat and just quickly tell me what some of your ideas in relation to data science and what you are thinking about doing in the future, in the near future, or you may have heard something that you think may be a good thing to do in your work and in your organization. So please feel free. I will just wait a couple of minutes. So use the chat box and see what you think maybe some of your questions in relation to data science. Anything that has crossed your mind in relation to data science. What is it? How it can be used? How to go about it? All of these things, just feel free and share your questions. Okay, we have the first question here: how data science can be used to improve services. Yes, we'll talk about that. Actually, that's one of the examples that I have prepared for today. Automating repetitive and time-consuming tasks, absolutely. Streamline some of the procedures in due diligence and data checking, and minimize errors. Yes, touch on that at the end. If we have time, if not, I will write some of the answers and I'll send them to all of the people who are today in the session. How to use data science for data migration projects. Yep, no, we'll talk about that. Potentials for enhancing productivity in analytics for any business. Yes, we'll talk about this thing as well. Okay, so that's great to hear. If any other things come to mind, please keep writing them in the chat box. At the end of the session, I will try to answer some of the questions, and the ones that I cannot, I'll just write the answers and I'll send them to you. So let's keep going then. So first, I would like to start with the definition. So what exactly is data science? Because there is a lot of opinions, a lot of answers. If you do a Google search on data science, you'll get millions of results. This is based on my personal experience, as I said, over my career working with data since 1994. So data science uses scientific methods, processes, and algorithms to extract knowledge and insights from noisy, structured, and unstructured data. At the end of the day, this is what we need to do. We need to we have a lot of data, and we actually need to get some insights from that data and make a decision on what we're going to do in our work or in our organization. Data science is related to data mining, machine learning, and big data, and we'll touch briefly on these things here. Yes, so data mining, machine learning, big data, you might have heard about these things. They are just parts of data science. Data science is actually broader than that, but they are included in this. So when you talk, when you think, when you hear about artificial intelligence or big data, yep, this is data science. So now, very importantly, this is Peter Drucker, one of the top management consultants of the 20th century. And he said something really interesting in one of his books for managers. And he said, the purpose of information is not knowledge. It is being able to take the right action. And this is exactly where we are in relation to data science. We don't do data science just to learn things. We learn things in university or at school or in other places. We actually want to be able to take the data, and whatever that data tells us, we want to be able to make a decision and do something in our organization. This is the whole purpose of data science. Data science is not about technology. Data science actually allows us to perform our tasks better, to run our organization better. Now, so data science is about business outcomes. This is really important to keep in mind. So data science is always about business. Data science is not about data. Data science is not about technology. Data science is about business. That's why the business people need to be very heavily involved in any data science projects. Data science is not for the technical people. They are the ones who actually help because they can provide the data, the infrastructure, and so on and so on. But it is the business people who actually need to drive the data science. So it's not a technical initiative. Data science is a business initiative. And also, it is an activity that 50 to 80% of auditors or any other professionals can do. So it is not something that only a specific group of people can do. It is actually everybody in an organization, or most people in an organization can do that. Auditors, accountants, marketers, HR professionals, and so on and so on. So what is that? Well, how exactly are all these things linked? Because we hear about data science, we hear about data analysis, we hear about data processing. This is how they link together. So data processing is concerned with storage and the pre-processing of data. Data cleansing comes into this one. Data processing usually is the domain of the technical people, data engineers, system administrators, database administrators, people like that. So data processing is very technical in nature. Then we move on to data science. Okay, so now data science is starting to become a mixture of technical and business knowledge. Technical and business professionals that need to work together. It includes big data, it includes artificial intelligence / machine learning, it includes things like databases, things like data warehouse. These now fall under the domain of data science. They need technical people to run them, but they also need business people to know to use them. This is the most important thing. Here we're talking something like Formula One. Formula One drivers are not automotive engineers, right? They are drivers who really well can drive those fast cars. And there is a separate team of engineers who actually build the cars, maintain them, and so on. So the drivers are not the engineers, and this is the same here. It is the business people who actually need to drive any data science initiatives and who need to use the data. It is the IT people or the technical people who actually help them and who build the solutions. And inside that sits data analytics. So data science is, data analytics is part of data science. It's a small part of data science. Data science is much broader. Data analytics is, the way personally, the way I see it, is kind of like simple data science or data science 101, where we're using simple tools, we're using smaller data sets, we're trying to answer simpler business questions simply because we don't have the capability. So Excel is one of the tools, for example, that can be used here. We can get a data set of employees with their addresses and the state where they live in. And for example, we can just basically do a quick search or quick filter in Excel and to work out how many people in our organization live in KL, how many people live in Johor, how many people are in Malacca, and so on and so on. So this is the beginning of data science. This is what data analytics is, and then we can do some more complex things when we move beyond that. So what are the benefits of the data science in enterprise? And I just want to show you here an example, which this is a real case scenario when data science, including big data and AI, was used in a global restaurant chain. Did McKinsey and Co., the consultancy, did the work, and they came to some really interesting conclusions. Now, first, using data science, they managed to improve profits and performance within the chain. So within 4 months after implementing the solutions, the customer satisfaction across all of the restaurants in the chain, so I don't know which chain, by the way, but just think somebody like maybe Taco Bell or McDonald's or something like that, Burger King. So don't know which one, but something along those lines. So customer satisfaction was improved by 100%. That's a pretty good result, I think. Sales have increased by 5% just from the use of data analytics. They haven't hired more people. They didn't open new restaurants. They didn't introduce new things to the menu simply because they used analytics in terms to monitor how their staff performs and what they can do in order to improve their performance even more. And they also got some really interesting new insights. If you look at this graph here, now, on the right-hand side, there are the circles, which are either red, gray, or gray with a red border. So now, the ones which are really interesting are the ones which are the red, the gray with the red border. These are the mist busting. They thought that they affect the outcomes, but they didn't. And if you look on the slide, on the screen, the fifth one from the top, where it says previous retail experience, is the myth buster. So using data analytics, actually, they realized that people who have previous retail experience do not perform better than the people who don't. Now, we all think that people who have experience in whatever area perform better than the people who don't have the experience in that area. But here, data analytics or data science, because they were using big data and artificial intelligence to analyze the data points, they actually came to the conclusion that previous retail experience doesn't matter for the employees. All right, that's quite unusual. This is a new insight that the company now can use in their hiring process. They shouldn't be asking for too much experience. They should be asking for other things. Now, then the other myth buster that was really interesting, compensation structure. If you go further down, that's about, I think that's number 11, the last one in the second group of circles. So it turns out that compensation structure, or how much money people are paid, doesn't matter that much. Well, obviously, it does matter within an extent. If you stop paying them, they are not going to perform, that's for sure. But increasing the money too much doesn't really make them perform better. So this is another one which is really interesting to think about, that just more money doesn't equal better performance. There are other things at play. So now, the other things that are also interesting, like when we look, number 3 from the top, demographics doesn't affect outcomes. Well, this is not exactly obvious as well. So it turns out that somebody who is 20 years old has got the same chance of performing in the same way as somebody who is 50 years old. Normally, we wouldn't think that. Okay, so 50-year-old, 20-year-old, you would expect that one demographic group would perform better than the other, but other demographics doesn't matter. Perform better than the people who live receives 5Ks from the restaurant where they're applying for a job versus somebody who lives 25Ks from the same restaurant, everything else being equal, probably it's better to hire the person who lives closer. There were some explanations for that. We're not going to go into too much detail, but this is what data science can actually tell us. Also, there are some obvious things. If we look further down, training capability building affected the outcomes. Well, we all know that training makes people perform better, but it's actually good to see it so that actually a manager can then speak to the HR manager and say, listen, we need more training because these are the hard results. This is not my gut feeling that we need to train the employees. These are actually the results of the data science exercise that we carried out, which show that we need to train more people. It's difficult then for an HR manager to say, no, that's not true, because we're talking here with hard data. So this is just one example where we have where data science has been used in relation to HR, but it does apply in an equal measure to a lot of other processes within the organization. So what exactly is data science in the enterprise? Now, it is something which is part of the daily business activities. This is not something which should be special. Once it's implemented and running, people should be treating it as part of their everyday job. Something that they normally do, they analyze something, they make a decision based on that. Some people already do it because when you are producing report, when you are looking at a report, or some kind of report from the finance system or from the HR system or from the sales system, you're making a decision on that. This is pretty much similar. It is not just software. This is the other thing about data science, because people think, this is software, blah, blah, blah. No, it's not. There is a lot more to that. It is a process. It is a process because we have to have a process of getting the data, of analyzing the data, from which system are we getting the data, how are we getting the data, how often are we getting the data. So all of these things come into place. So there's a process. So things are a little bit deeper, just getting a data set on a USB from somewhere and analyzing it. So there needs to be a process. The second thing is the data sets. Which data sets are available to us? Which data sets are available inside the organization? Which data sets are available outside the organization? For example, if you think that the level of interest rates impacts the results of the analytics that you want to do, then you may look, if you're in Malaysia, you may look at the site of Bank Negara, because it will have the data about interest rates. If you are in Australia, you will be looking at the site of Reserve Bank of Australia, because it does have the data set with the interest rates. Actually, it's a historical data set. So we need to work out which data sets we need, where do we find them? Are they internal? Are they external? Sometimes we can generate the data sets, or sometimes, like for example, the study that I showed you with the global restaurant chain, they actually attached sensors to the people working in the restaurant in order to generate data. So that's how they measured the quality of interaction, which was one of the parameters there. So using the sensors, they measured how often and how often the employees come close to each other and how long do they stay together, which means basically they are talking about something. So using that, they measured the interactions. So the quality of interaction, which was one of the inputs into that data set, was generated on the spot using sensors. So these are all of the considerations that we need to have in mind. And then which tool are we using? Are we using something like Excel? Are we using like business intelligence, something like Microsoft BI or Tableau? Are we using KNIME, which is a very powerful tool which allows fairly simple tasks, and you will see a demo of KNIME today, simple to complex tasks and anything in between. So all of that is part of the data science. So we need to be mindful what do we actually do with data science and how to approach the whole thing. Now, data science doesn't affect the business objectives. We know what we want. We want to improve the sales function. We want to improve the procurement function. We want to improve the vendor management. We want to reduce the losses from fraud. All of these things are still the same. Data science is there just to help us do it better. and for less money. Now, where can data science be used in an enterprise? Pretty much everywhere, to be honest. We need highly automated data-rich processes, which is the case for most medium to large organizations and governments. So some examples here include payroll, HR as well, purchasing, all of the data on vendors, on their performance, on the documentation that they send us, maintenance, for example, if you work like, for example, a transport company, maybe trucks, maybe if you're using trucks or trains or planes, maintenance, the maintenance function can benefit from data science, and it already has got the data in a system somewhere. Sales, pretty much any organization except government ones, even they to some extent are involved in sales. So there is a sales system. We know the data is available there. We can analyze it, and a number of other systems. So the list is pretty much endless. So just keep in mind that data science can be applied anywhere in the organization, as long as there is data. And in today's organizations, data is everywhere. So just a quick overview of data science, the simple data science, which is basically data analytics, the way I see it. So data analytics or data science 101 is a or semi-automated process. You decide to do something, you go and speak to someone, you put in a request, or sometimes you don't even need to put a request. You get a data set from somewhere and you do something with it. So this is based on a relatively well-known software. Like one option is spreadsheets, Excel most likely, or any other type of spreadsheet that you may use. Like if you are based on a Mac, it can be the numbers, it can be Open Office, it can be some other, it's a spreadsheet of some kind. Another option, some specialized software like Tableau, for example, NIME, the one that we use at MBS Academy when we run our training. As I said, NIME is very powerful. It's also free, so it allows us to actually use NIME in our courses without actually having additional licenses. And NIME is also free for organizations to be used. So it is actually very beneficial. Data sets are also mostly with simple structures. It's basically one table, rows and columns. That's about it. This is the data analytics. This is when we get a data set of all of the employee leave, accumulated employee leave from HR, and we just identify those who have too much leave. We saw the data set in Excel. It might have a few thousand rows. We get the top 10, and you see who are the people who have too much leave. Or we can filter and say everybody with more than 8 weeks annual leave, show me that. But it's a simple structure. It's basically it's a two-dimensional data set, rows and columns, just a single data set, and that's basically it. And usually the data sets are not very large. Now, large is very relative, to be honest, and some organizations see large as hundreds of millions of bytes, terabytes or petabytes. Some other organizations, when they get to 100,000 rows, that's large. So that's relative. But generally speaking, when we talk about data science 101 or data analytics, it's basically simple thing that can 100,000, 200,000 rows, something like that, something that would fit in Excel quite easily. Not very large, because once we start moving into large amounts, we need to apply different solutions. But here we're talking about simple things, so up to 500,000 probably we can consider it to be a relatively small data set. For a lot of organizations, actually, that's more than enough, by the way. Now, what is the process? How do you actually do the data science 101 or data analytics? Number one, review the business objectives. What do you want to achieve? Okay, so for example, we may want to improve the sales. Now, what are the business questions and related analytics that you need to do in order to achieve that objective? We want to improve the sales. Well, one option is to identify what are our best-selling products in quarter 2 and what are our worst selling products in quarter two. And then the next thing is to see how much money we spend on advertising for the best and for the worst selling product. It just reminds me, actually, last week I watched with my kids the movie Intern with Robert De Niro and Anne Hathaway. If you haven't seen it, it's a really interesting, light-hearted movie. Robert De Niro is a 70-year-old guy who retired, and he went to work as an intern for a new e-commerce company. And actually, he did some analytics there, and he showed them, and all of these young people didn't have a clue actually about that, but he showed them that actually they're spending the most advertising on the worst performing products and very little on the best performing products. So now they can say, okay, and then there was a discussion there, and they decided to do something with it. But this is the type of thing that you can do. The business objective, improve sales. Then what are the business questions? What are best-selling products? What are worst-selling products? What are the best salespeople? What are the worst salespeople? And so on and so on. And then we perform the actual analytics. Okay, so we identify the top products, we identify the 5 bottom products, we identify the advertising spend per product, and we actually start making decisions based on that. We examine the output, we see what are the products, the top, the best, the worst, the best salespeople, the worst salespeople, and then we incorporate the results in our daily activities. So we actually can start analyzing that on a daily or weekly basis. What are the top products? And monitoring over time. How are they performing? What are the best salespeople, the worst salespeople? Again, it becomes part of our everyday activity. It's not something unusual. We start using it regularly more and more. So this is a very simple description of the process. Some examples. In sales and marketing, as I said, let's identify the best-selling products in each region. So if we are multinational, what is our best-selling product in Indonesia? What is our best-selling product in Thailand? If we are a national Malaysian company, we can decide to do it by state to work out what is happening everywhere. So what is our best-selling product in Sabah? What is our best-selling product in Sarawak? What is our worst-selling product in KL? Worst-selling product in Johor, and so on and so on. So this is just one of the examples that we can do. What are the top salespeople in each region? What is our top salesperson in Johor? What is our top salesperson in KL? Maybe it's the same person, or maybe we have identified territories for each person. We have assigned them to them, and there's 5 people for KL, there's 2 people for Johor, there's another 4 people in Sarawak. We want to know who is the top one, because at the very minimum, we can actually get them to train the other people who are working in the same territory and teach them what they do. In HR is another area where we can do some simple data science. One example, what compliance training has to be done this quarter? There is training which is compulsory. Like, for example, in Australia, if you are an electrician, and there are also some other occupations, but I know about electricians because I have friends. They told me that they have to do first aid refresher every year. So the question is, we are a company and we employ 100 electricians, and it's compulsory for them to do the training within 12 months of the previous training. So the analytics is who had to do training this quarter, okay? Whose training, whose first aid certificate has expired this quarter, so they had to renew it essentially. And then we can check, these are the 12 people who had to be doing who had to do the training. The next check is, did they all do the training? Because if they haven't, we're having problems here, because if something happens tomorrow, the organization will be liable. It can be sued by the employee, by by customers, by other people. So now we can see, okay, 12 people had to do the training this quarter. 12 people have done the training this quarter, so we're good. There is no problems here. But if we had 12 people who had to complete the training this quarter, and only 7 people did it, that's a problem. we very quickly need to find the remaining 5 and send them on training, get them to finish the training because their first aid certificates have expired and they pretend their potential liability for the problem, for the company, sorry. So this is another example how you use data science, simple data science in compliance, in HR. Now, when we start moving into more complex things, things are a little bit different. So data science 201, this is true data science now. Now, again, this is can be ad hoc or semi-automated process, but here now we're starting to use different tools. It's not just one data set. We actually need to have a relational database of some kind. Can be Oracle, can be MySQL, which is another Oracle product, can be SQL Server, which is a Microsoft product, but we want a relational database of some kind. Any of these, or there's enough others, doesn't matter which one. The question is that it's a relational database because we have multiple data sets. We also look at different tools. KNIME, again, pops up here because KNIME is a tool that allows you to extract data from databases and analyze the data very easily on the spot. And then we start looking at data sets with complex structures. Now we have more than one data set. Like, for example, if we are looking at sales, we have a data set of sales transactions. We have a data set of salespeople, which is a subset of the HR employee data set. We have a data set of customers. We can have other data sets, so we can actually need to link all of these things together in order to be able to analyze them. So instead of just one data set, we're starting to have more than one. It is a little bit more complex. It's not rocket science, so you don't need a degree or PhD in data analytics or data science, but we're moving one level of complexity up, but we're actually able to do a lot more. Data sets now can be very large because when we put the data set into a relational database, the limit for Excel, just as an example, is 1 million rows. That's a theoretical limit because with 1 million rows on some analytics, it takes such a long time that it's almost useless. But in a database, 1 million is nothing. We're talking here multi-million data sets, multi-million row data sets, because for some large organizations, transactions can be quite huge. I have worked with a university here. We were implementing an HR system, the HR monitoring system for them a few years ago, and they had a data set of 150 million records. It was every single payment that has happened since the system was put in place. 150 million, and this is not the most, actually. I worked in Sydney, I ran training for a software company, and they told me that they didn't tell me what was the number of rows, but they told me that they have 400 terabyte data set per month coming in. So 400 terabytes, that's 400 million gigabytes, just to put things into perspective. So we're talking about some large things here. And also the data sets are now from multiple sources. You can actually link different systems because quite often organizations have more than one system. I'm yet to see an organization that have just a single system for everything. There can be one system, either SAP or Oracle, which is covering, let's say, 60 or 70% of the needs, but then there is a number of other smaller systems for specific tasks, and you need to be able to amalgamate these. I was in Turkey 5 or 6 years ago looking at the operation of Bosphorus ferries as part of a delegation. We were looking at their best practices. For example, they had several sales systems because they had a different sales system for online sales. They had a different sales system for buying tickets at the terminal when you were waiting for the ferry to board it. And they had a different sales system to buy tickets on the ferry from memory. Now, that was 5 or 6 years ago. Maybe they have one now, but this is just to show an example to show you that different systems for exactly the same purpose. It is sales transactions. So you need to amalgamate those, to be able to get the full picture of the sales. Otherwise, you're just looking at one. Now, when we start looking at using relational databases and looking at more complex things, doing more complex things in data science, it's quite possible to do these things. Some examples, again, going back to HR, what personal characteristics reduce staff turnover? Because you can actually model and see when you hire a person. Now that goes here into artificial intelligence. This is an exercise that I have shown at a conference in Malaysia in 2019. So what personal characteristics? So it's possible to look at all of the staff hires over the last 5 years and see which people left after 4 months and which people stayed with the organization for more than a year. And the people that left after 4 months, it's possible to actually look at their characteristics, gender, location, age, education, so on and so on, and actually see if there is anything common. It may not be, can be totally random, but sometimes maybe it's possible to identify a common characteristic, in which case, this is a warning when we're talking to someone. We need to be able, with the interview, if they are potentially one of those groups, we need to be able to see what we can do and to work out whether they are going to leave in 2 or 3 months, causing a lot of headache and financial losses for the organization, or they are going to stick for a long term. But this is just an example of more complex data science. Again, sales and marketing. Now, we want now to go deeper and to identify, link the products and the sales and the sales transactions and the actual salespeople data sets, and to see what are the top salespeople per product, not the top salespeople in general, because there can be a person in, let's say, in KL, where we have our biggest sales force, who is not one of the top 3, but they are the top in one specific product. We want to know that so that we can actually focus on them and tell them, okay, if you're so good at selling this, why don't bother with anything else, just focus on this product. We just get them to do what they do best, and we get the other people to sell other products. Maybe it turns out that each salesperson has got a specific strength. So in this case, the most logical thing is to actually assign each salesperson where they perform best, as opposed to asking them to sell everything or sell several products. So this is an example where we're linking several data sets and making more complex analytics. Now, identify the best advertising channel per person per product. Per product per region. So now if we're selling product A in KL, in Johor, and in Sarawak, and we are advertising on Google, on LinkedIn, and on radio, we want to see what is the performance. Is radio good in all these regions? Because maybe in one of the regions, radio is performing really well, while Google and LinkedIn ads are not so good, or Google, let's say Google and Facebook ads are not so good, in which case we might just forget about Google and Facebook. In that state, we can just focus on radio. And in another place, let's say in KL, for some reason, Google is the best performer, while we hardly get any return on investment from the spend on radio. Well, if that's the case, we just do Google. Why bother wasting money on radio if we're not achieving anything? And we can also do it on the level of individual products for each region. So again, this is another example of more complex analytics. Banking and finance, anti-money laundering is one of the areas where data analytics can be used, data science, so it can be used with really great success, because we can now start looking at people doing a lot of small transfers, because in Australia, bank transfers or bank transactions under $10,000 don't need to be reported. Bank transactions over $10,000 need to be reported by the bank, and they go into a special register. So if you want to transfer money and to launder money and transfer them from point A to point B, and you have $500,000, for example, one of the things to avoid too much scrutiny is to actually do 51 transactions of $9,990, in which case these transactions are not reportable. We can actually transfer the money from bank A to bank B or wherever it's going, and it won't be that easy to uncover. But if we have data analytics, it's very easy because we can actually see these transactions. We can go through all of the transactions that the bank performed in the last 3 months. We can see transactions with similar amounts, something around 9,900, can be 9,910 or 9,989, 9,870, that type of stuff. We can actually identify that, and we can get a potential indicator for money laundering and alert the authorities and perform some anti-money laundering function. This is what the banks do. And some of them do, some of them, there are various levels of maturity, but this is how you can use data science in anti-money laundering. Some other examples: fraud detection. Fraud is an issue around the world. 5% of the turnover in an organization across the board, government, private, not-for-profit, doesn't matter, is lost. 5% on average is lost to fraud. One of the ways to detect fraud is using something called Benford's law, which says that in a data set, like let's say all of the amounts on an invoice, this is a data set, the amounts that start with 1 need to be 30% of the numbers, 30% of the amounts. The amounts that start with the digit number 2 need to be about 17%. This is the second bar. The last bar, 9. The amounts that start with 9 need to be only 5%. So basically, 99 ringgit, 927 ringgit, 99,521 ringgit, 9,100,000 ringgit. These amounts that start with 9, there needs to be only 5% of them. If there is more, there is a problem. And here's an example where it is a real example actually, where you can see that the green line here shows the theoretical Benford distribution, the same as the chart on the top right. The blue bars show the real one, and you can see that number 5 is below the predicted percentage, and number 4 is above. And actually, this is a real case in a bank in US where there was a policy that loans up to $50,000 were approved locally by the branch manager, and loans above $50,000 had to be sent to the central office to be approved by a panel of 3 people. What happened? People who had friends, who were friends with the bank managers in more than one branch, what they did, they would go for a loan, and the bank manager will say, listen, we can give you $51,000 loan. You can put it in the paperwork. We'll send it to the central office, and it will come back in 2 weeks' time, and you'll get an answer, yes or no, whatever. But he said, if you can drop the amount below 50,000, just a little bit, maybe 49,900 or 49,100, whatever, 48,000. If you drop the amount below 50,000, I can approve it here on the spot. It will take me 3 days, and I'm the only one making the decision. And a lot of people said yes. When you hear the situation like that, you think, well, I can actually probably skip $3,000 if I get it on the spot here. And as a result, loan approvals at around 49, 47, 48,000 were a lot more than the predicted versus the ones around 51,000, 52,000, 53,000. And that's how, using Benford, they actually discovered the fraud. This is again an example, complex data, more complex data science, where using the data, they could discover something that would have been really difficult to identify otherwise. Couple of quick demos now before we finish. The first one, just give me 1 second. So what I would like to show you here is one of the exercises that we do in our courses, in our training. This is what we give to the people that we work with. So we use we use it, as I said, we use a tool called NIME, and we give step-by-step instructions to the students, and they perform the analytics quite easily. So what they have to do here is, just give me 1 second. So I will share my screen now. So here's my screen. On the left-hand side, you can see the instructions for the exercise, and to the right-hand side, I will actually do the exercise for you on the spot. So we'll start a new NIME workflow. I've already done that. I have downloaded the data set. By the way, you can get access to this exercise in order to try it at home after that. So first, I will read an Excel spreadsheet. So I will get the XLS. The Excel reader. This is the Excel reader. No, I'll double click. It will appear. Here I will load the Excel file, which I already have. Okay, so this is my Excel file, which I have loaded. I will right click on it and execute it. And I have, as you can see at the bottom, I have a green light under the node here. So see the green here on the Excel reader, which shows that everything's okay. And then what I will do, I'll get another node, which is called row filter. It will link to that, and I will actually configure it. I'm just doing that quickly. As I said, you can get instructions and to share them. And I have the row filter here, like what you see at this moment. And now I want to be able to execute it. Yep. And I want to show the data set. I'll just make it quicker. So I have 4 records which are paid over $5,000. Very quickly, I went through the data set. As you can see, there is no programming. There is absolutely none of that. I can see here what are the records. You can, sorry. So as you can see here, we have 2 rows from accounting in the middle. 1 row from marketing and 1 row from payroll. On the next part of the exercise, I have a question. How many payments are there for marketing? Well, there is 1. For accounting, there is 2. For payroll, there is 1. I can check, yes, I got it right. So this is this is a very quick analytics where we can see something. We have a data set, we read it, there is no programming. You just need to be able to drag and drop those little excuse me, colorful figures, blocks on the canvas, random. So you need to know how to configure them, of course, but this is a very quick learning curve. When we run our courses, usually the first time people see it, they're a little bit confused. By the end of the third or the fourth exercises, they're just going through it like that, like the way I did now. They usually take half of the allocated time, simply because the tool is very user-friendly, business user-friendly, and easy to use. I want now to, this is a simple one. I want now to show you something much more complex, actually, where it is, where we use KNIME for identity fraud detection. As you can see here, in this one, I had only 2 nodes, while here, in this workflow, I have a lot more. What you can see here, we won't have time to. So here, this is the complexity. This is a real solution developed in KNIME. It's working. What you see here, all of these nodes are designed to analyze the activities of someone on Facebook, Twitter, and also the way they write their answers on a credit application, and using that to determine if that person is a fraudster or it's not. This is designed for use in the banking sector. Each one of these little gray nodes here that you see, each one is a so-called meta node, and actually there is a set of different nodes which are sitting inside it. So KNIME can be very complex, and KNIME can be very simple. So this is just the content of one gray node. This is the reason we're using KNIME, because it's a free tool. It allows you to quickly start doing simple things, and over time it allows you to easily progress towards more and more complex things. So these are just the 2 data, the 2 quick demos that I wanted to show you. I will go back to my presentation now. And I will have a look at the, excuse me, at the question shortly. So this is data science 101, the simple one. This is the HR analytics, data science 502, which includes big data, and artificial intelligence is the second one that I showed you for fraud detection. Both of them, however, are done using the same tool, which is the important thing. Now, just quickly before we finish, what I was talking about today is one of our standard training courses. If you are in Malaysia, we are registered with HRD Corp, and the course is claimable. This is an overview and the outline of the program. As you can see here on the right-hand side, program outline. There are several modules which are part of this thing, of this course. The course runs for 18 hours, 3 sessions of 6 hours each, and contains this content here. This is just for your information. Also, I want to quickly go, if you are interested to learn to participate in our training, some of the things that I suggest you can do, speak to your learning and development team within HR, because they are the ones usually who are responsible for training. They manage training, they know what the processes are. We are HRD Corp registered, so that means that all of our training is claimable, and when you come to training, or when we organize training for for an organization. It's something that the organization can claim, so the training can be free in most cases. After you've spoken to the L&D team, contact us on this email address or through our Facebook or LinkedIn page, and organize a meeting so that we can discuss your specific training needs. We can customize our data science training specifically for your organization using relevant case studies. We do that for every training, for every in-house training. At the moment, actually, I'm talking to someone about that, and we can take it from there. So this is the end of our session. Thank you very much for Thank you very much for being here. And you can contact us on these are the channels to contact us.